My name is Vardhan, and on behalf of Edureka, I will be delivering this session. And this session is about the difference between the applications which are implementing SOA, which is service-oriented architecture, and software applications which are implementing the microservices architecture. So without wasting any time, let me get started. Now, before we go into details about SOA and microservices, let's see what is a monolithic application and how that functions. First of all, you can think of a monolithic application as a container which is basically hosting a number of software components, right? There can be a number of software components as part of your software application. And if they are all hosted together and delivered together, then that's called a monolithic application. Now, there are various challenges with any software application which is implementing the monolithic architecture. First of all, they are not flexible. Okay, monolithic applications, they cannot be built using different technologies. That's the problem. The second challenge is that they are unreliable. Even if one feature of the system does not work, then the entire system will not work. The third challenge is that these monolithic applications are not scalable. They cannot be easily scaled, and even if the application needs to be updated, then the complete system has to be rebuilt. The next problem is that with these monolithic applications, they block continuous development. All the features cannot be built and deployed at the same time. They will have to be done separately. The next challenge with monolithic applications is that the development is very slow. They take a lot of time to be built, since each and every time every feature has to be built one after the other. And most of all, the monolithic applications are not fit for complex architecture, because of course you cannot use different technologies. You are very limited and very constrained, right? So that is the challenge with monolithic applications. So now let's go on to SOA, which is nothing but service oriented architecture. Now with SOA, these services or features, they are broken down, right? The entire software application is not built as one, but the different features and the different services are broken down into smaller components, right? So that's why it's called coarse-grained architecture. And over here, if we have, let's say, one software application inside which it provides, and if it provides like 5 features or 4 features, then all those 4 features are delivered by 4 different services. And that is what you can see over here, right? There are 4 different services. And each of these services would have multiple tasks inside them. And these smaller tasks are together delivered as one particular feature. And the whole software application comprises of a number of these features. But with microservices, it's a little more different. Now, these features or services are further broken down into task level services. So here it was feature level services, whereas the services here, they are task level. Each and every task in a particular feature, that was broken down, and that's why you have multiple tasks and multiple services in a microservice architecture. And that is why this is called fine-grained architecture. So that is what the differences are between these three on a high level. Now, before I go further and confuse you people, let me just go into more details about the differences between SOA and microservices. You can think of the difference between SOA and microservices with the help of these images. So SOA is like an orchestra. Similar to you having multiple performers, you will have multiple services, but each of these performers will be controlled by one particular director. And similarly in SOA, even though you have multiple services, these services will be interacting with one another, and then they will be delivered as one particular software application. But whereas in case of a microservice, there are multiple, or let's say there are independent performers, but these independent performers are not controlled by any director. So they work separately, and they work in silos. So that is the difference. So I hope you can understand the difference between the two from these images, right? Even though they work together, they are controlled by one particular director. And that's why this is called a centrally governed architecture. And whereas microservices, you do not have a centrally governed architecture, and that's why it's called a decentralized governing architecture. So let me go forward and talk about the difference between these two, which is nothing but microservice and SOA, with respect to certain parameters. Let's look at the difference between them with respect to architecture and coordination. So first of all, in SOA, there are 4 different types of services. First is business service. The next is enterprise service. Then we have application service, and then we have infrastructure service. So these 4 service types together form your SOA, and they together deliver your software application. Now, what are these different services and what do they do? Let's see that. First is business service, right? So your business service is the one that's going to be performing your core business operations, and it can be either represented by XML or by web service definition language. And then we have enterprise service. The enterprise service is that service which implements the functionality defined by your business service. And the enterprise service does it with the help of the application service and the infrastructure service. Now moving on, we have application service. The application service is the actual core application or the core functionality of that feature. And these application services can be either invoked directly or they can be invoked through a user interface. And now we have infrastructure service. The infrastructure service refers to those non-business or those non-technical operations such as auditing, scaling, or security, and all these things. Those are the different services in a SOA. But in case of microservices architecture, you do not have these many types of services. You just have a functional service and you have an infrastructure service. The functional service is basically the combination of a business service, an enterprise service, and an application service. Now, a functional service is a fine-grained service. So basically, if your business logic or your business operations requires a particular feature to work, then the task that is related to exactly that particular feature, that is performed by the functional service. And besides the functional service, we have an infrastructure service. And the infrastructure service over here is very similar to the infrastructure service that is there in SOA. It does all the non-business or the non-technical operations such as your security, auditing, and logging. Okay, so that is the difference with respect to architecture and coordination. So now moving on to the next slide, we have heterogeneous interoperability. Now what this means is any software application need not be developed on the same programming language. Now in your main software application, you might have smaller applications, right? And each of those smaller applications could be written on Java, or it could be written on .NET, or it could be written on C# or Python or anything. Now, when it's written in different programming languages, it's tough for them to interact with one another. And if you want the different services to communicate with one another, then you would have to bring a particular platform, right? So that's where you have this messaging middleware. So in case of SOA, there is something called as a messaging middleware, which acts as the communication point or the interaction point between the different applications which are in a different language. So you can see that this application is on either C# or .NET, and this is on Elastic Java Beans, right? Similarly, here it's C++ and here it's Java. So, and all of these communications, they go to this one particular messaging middleware. But in case of microservices, we do not have any broker here. The communication happens directly between application to application, even if they are in different programming languages, even if they are structurally different, and even if they are built in different grounds. So look at this. If you have a C# or a .NET application which is communicating with a Java application, but then how does it happen? It happens with the help of a REST API. There is direct communication between these two services. And similarly, if you have another Java application which wants to communicate with another Java application, the communication would take place with the help of REST API. And similarly, Java to C# or .NET would again take place with the help of a REST API. So there is no broker here or middleman, which is a messaging middleware. The communication is directly to the other application. Then comes service granularity. If you can remember, I earlier told that in microservices, you do not have the software delivered as a whole, right? It is broken down into smaller features. And if you're basically performing an operation which involves multiple applications or multiple services, then those services are called by one another when it's needed. So as an end user, as a consumer, you might be performing one operation, okay? So that one operation would not be calling all the different services. It would call one service, and this service, when it needs to interact with the second service, this would make the call to service 2. And similarly, your service 2, when needed, it would call service number 3. And similarly, once the service request is made, the service response is also given to the one that's invoking the request. Now the catch here is each and every service request and service response takes 100 milliseconds. Okay, so let's assume it takes this much time, the API calls. And this is in case of microservices. So in the microservice architecture, when each call takes 100 milliseconds, in total, for this service to get successfully returned, it would take 600 milliseconds. Now that's an awful lot of time for an API call to complete successfully, right? For an API call to be made successfully and to be returned. And this is where it is different from an SOA. So in case of an SOA, the service consumer would again be calling, would be performing one particular operation. And what happens here is this operation would be calling the different services all at the same time. So the operation over here would be calling the service number 1, service number 2, and service number 3. It should be encompassed all together. So one particular call would be made to the service, and all three would be serviced at the same time. And by this, you would be saving time, because all the three requests and responses would be made simultaneously. So you would be saving a good 400 milliseconds over here. So that is the difference in service granularity between SOA and microservices. So the next difference we are going to see is with respect to component sharing. This is very similar to the previous slide again, right? Because then it would be the same order service which would be interacting with your different smaller applications, each for customer management and for warehouse management and for order fulfillment. And the data again would be stored in different databases. But there again is the difference in microservices, because in the microservices architecture, for each and every application, so for customer management, we have a separate order service, and that order service would be accessing its own database. For warehouse management, you have a separate order service, which would be accessing a different database. And then for order fulfillment, which is again a different application, this would be using a different order service, and this order service would be using a different database from where it would be accessing data, right? So that's how there's a difference in even component sharing between these two architectures. And then we have the next difference between them, and that is the middleware versus API layer. This we also spoke about earlier, right? Your SOA uses middleware for communication, and your microservices uses an API layer for communication. So that is about the differences between SOA and microservices. Now let's go ahead and look at the differences between the two by understanding with an example of a shopping cart. So every e-commerce portal will have a shopping cart, right? Where you can add your products to the cart and then you can check out later. So for adding an item, for removing an item, for checking what is the tax, for checking the total bill amount, for all those things, you have a shopping cart application. And then finally, we have another application, which is the main application, which gives details about the product. So it will give us details about the product name, what is the product ID, what is the product rate, how many quantities are present, and all different other options, right? What color the product is and all these things. Now, these are three different applications, and when they work together, you get the complete software application, right? Now, each of these applications would have smaller tasks. A shopping cart application, like I told you before, it would have an add or remove functionality where you can add a product to your cart, you can remove a product from your cart, you can check what is the bill in your cart, you can check out what is the tax that is there, and all these things. Similarly, if you talk about a product catalog, you have other tasks, right? So all these tasks together form one particular application service in case of a SOA shopping application. But in case of microservices shopping application, each of the different tasks that these services provide, those tasks are broken down into smaller fine-grained services. So here we have feature level services where shopping cart is one feature, product catalog is one feature, and user account application is one more feature. But in case of microservices, we have a separate billing service. For shipping, we have a shipping options service. We have a tax calculation service, right? So the different tasks in this particular feature, it's broken down. Similarly, for product catalog application, we have different task level breakdown, such as display product service. We have an update display service. We have user default service and many more. Similar for user account application, right? We have a send email service and many more. Now that you've understood that microservices is all about breaking a particular feature or a feature level service into task level services. So let's see how microservices shopping application is different. So first, let's take the case of where a microservice shopping application is better. So here we'll have certain features which are common to multiple applications, right? So we have something like a display image service. So it's a smaller task level service over here, but the image of the product being displayed might be common across all the three applications. It might be present in the shopping cart also, and the image of the product might be present in the user account application also, with showing which are the products which the particular user bought. And then you might have the product, you might have the image of the product in the product catalog application also. So in this case, if there's a change in the image dimensions or in the license of the image or anything with respect to the product's image, then the code of course would be similar in all the three applications, right? The code may be similar, but the code has to be changed everywhere, right? And when you change the code, when you rework, then it causes a lot of problem again. Now, when you change the code here, you're changing the functionality, and that might cause this particular application to behave abnormally. It might have bugs, or the application might cause failure. And similarly, if you change the code over here, then even this might throw errors and you might have bugs. Similarly to this particular application also. So if you want to avoid all those things, you have to test each of these applications separately after changing the code and after updating the required details. And after testing it, you will have to deploy each of these applications, and you have to deploy them separately. Now, all these things is time consuming, right? So it is the same change that you're doing across all the different parts of your application. But even though you're doing it everywhere, even though you're doing something similar, you will have to test and deploy each of them. And sometimes you might have errors in only one particular application and not everywhere. So these are all time consuming tasks. But if it's in case of a microservices shopping application, you would not have this problem, because all the different tasks over here, they are provided as a service. If you want to change the way the product's image looks, then you will have to change only this particular application, right? So by only changing this service, your job will be done. You do not have to worry about the other services, and you do not have to change anything over there. So the main change you will have to be doing will be restricted to only this particular service. So you save time and you save effort over here in case of microservices shopping application. Now, this was a use case where the microservices shopping application was better. But then there are also times when an SOA shopping application is better for you. So this was a classic use case of where a microservice shopping application is the best fit. But let's see a use case where an SOA type of a shopping application and the SOA architecture comes out better. And that example is when your product is not actually that big. So in this case, yeah, you have a lot of functionalities, you have a lot of features and tasks. So just consider the example of a very simple software application which needs three primary functionalities. One which has a shopping cart, which into where you can add your items, and then you have another user account application where you'll have the user profile, and then you'll have a product information application, right? So over here, all these different applications will not have too many sub-level features or sub-level applications. They are very straightforward, they are very simple. In this case, if you're implementing microservices architecture, then you will have to go through a lot of trouble, which can simply be avoided because your application is in itself very simple. You have to just create one website where you can have one website in which you have a cart wherein you can add your products which you want to buy. Then when you're checking out, you can have the user information displayed, and then you have details about the product, which is a separate application. So in this case, it could just be these three different services. So that is the difference between an SOA. So I think by now you understand that neither of them is better than the other, right? So there are times when microservices is preferred, and there are times when SOA is preferred. And you cannot hardcore it by saying that one is better than the other. So on that note, I would like to conclude today's session. So guys, thank you for being till the very end, and happy learning from Edureka.